Good evening and welcome to the National Building Museum. My name is Scott Kratz. I'm the Vice President for Education here at the museum. And tonight's program is the second in a brand new series called For the Greener Good, Conversations That Can Change the World. The goal of this series is to bring together the nation's leading experts to discuss sustainability and the built environment. The programs will track how we've arrived at our present situation, the anticipated and unexpected effects of the green movement, and offer considerations on a path to a more sustainable future. It is important that these programs provide not only solutions, but also how you, the audience, can participate in creating a better future. And I must say, on a day when temperature reached over 80 degrees here in Washington, D.C. at the end of October, and wildfires are scorching a very dry Southern California, it underlines our collective need to work together for a more sustainable tomorrow. As part of that effort, one of these programs are meant to be conversational in format. We will break periodically during the program to take questions from the audience. And in an effort to get in as many questions and responses as possible, I'd ask you to be as succinct as possible while asking your questions. And then at the end of the program, we'll invite you to continue the conversation with the participants in tonight's program, as well as those sitting next to you, during informal refreshments in the museum's West Court just behind you. At that time, museum staff will be on hand to prompt feedback about the program and also to encourage further discussions about issues that were raised this evening. If you like what you hear and experience tonight, we invite you to our next program in this series entitled Going Green, Carrot or Stick on November 19th. As with the other programs in the series, we've invited speakers representing a diversity of professions and views to discuss the best way to encourage green building design. Government mandates, financial incentives, or a little of both. We'll be joined by the Green Building Coordinator of the Department of Environment at the City and County of San Francisco, a professor of law at Widener University Law School, a manager of state and local advocacy at the U.S. Green Building Council, a director of sustainable development from the Peterson Companies, and moderating the program will be a deputy editor of Architectural Record and a consulting editor of Green Source. The For the Greener Good series tonight, and the entire series, is presented by the museum's sustainability partner, the Home Depot Foundation, and we would like to thank them for their generous support of this innovative lecture series. Before we begin, can I get an idea of who's in the audience? It will help the panelists know who they're speaking to. Can I ask, and I hope I can see with the lights, can I ask if there's architects in the audience? A few hands. Engineers? A few more hands, that's great. Journalists? A few hands. Any federal employees? Who am I leading out? Feel free just to call out. Developers? Students? I missed that one. That's okay. That's great. We welcome you to, we look forward to all of your questions midway through the program and at the end of the program. And as we are trying something new with this format of the series, we have a very special treat for you this evening. The National Building Museum is very proud to premiere The Future of Energy, Coal or Nuclear, from the documentary series E² Energy, airing on PBS in November. We will run tonight's event, we'll begin tonight's event after a few more introductions with the screening that runs approximately 25 minutes. After the screening, we will host the discussion led by Matthew Wald, a journalist for the New York Times, where he's been writing about energy since 1979. We've assembled some of the nation's leading authorities on the subject, and I know you'll be in for a very rich discussion and conversation. Now, please join me in welcoming Brenda Disher, who's the Director of Marketing Manufacturing Solutions Division at Autodesk, who sponsored the E² series. Please welcome Brenda.
Can you see me over this podium? Because of the lights, I will try to stay at the podium. I'm normally walking around. So welcome. It is also my pleasure to introduce all of you to this event. Autodesk is very excited to sponsor this second year of the E² series. We are also proud to be partnering with Constellation, who is our sponsor, and you'll hear more from them in just a few minutes regarding this very vibrant and important issue. But before I spend just a couple minutes talking about why Autodesk, a software company, is committed to sustainability, I thought I would talk a little bit about how the definition of sustainability has evolved over the last several years. What's interesting is in the early 80s, sustainability was really defined more as, and I'm going to read the definition, meeting the needs of the present without compromising the ability for the future generations to meet their needs. Interestingly enough, we coined the phrase, or we talk a little bit about, that's the idea of doing less bad, which is what all the sustainability discussions were in the early 80s, do less bad. What's interesting, most of the conversation today, and a lot of what you'll see in the documentary, a lot of what you'll hear from some of the panelists, is today the issue of sustainability and the conversation around sustainability is about what we all do and how we are all responsible to improve the world, the planet around us. And that's a very different definition. That's about doing more good, quite different than do less bad. And interestingly enough, that definition has a lot of relevance for Autodesk as a software company, because the approach to doing more good has a lot to do with technology, with design, and with innovation. All things that are critical to the success of our company, because we work on these things every single day. So specifically, let me talk about Autodesk and why we're committed to the sustainability initiatives. We at Autodesk are committed to not only the environmental awareness, but also to sustainability design, because it's part of our installed world network of customers. We have over 8 million customers in the world that are designing everything that you see every day. And I know from the hands in the room, there were quite a few architects in the room, but very few architects, engineers, designers, even mechanical engineers, mechanical designers, civil engineers, almost all use our technology and our software. AutoCAD is the most prevalent technology used in the world for designing buildings, bridges, every piece of mechanical component that you usually use or see, and most of the consumer products that we use and touch every day. So if all those people around the world are using our technology, and we can give them the capability to build in better designs, more sustainable designs, more importantly, build in sustainability earlier in the design cycle, then that can help us, and we have a responsibility to help the planet become a better place. And that's really the thrust of why we're interested in sustainability. Specifically, there are four particular four positions which we have of our ability to promote more awareness around the environmental issues and specifically promoting sustainable design. 4 key tenets. First is through everything that we do in our products. We've started a considered effort inside of all of our development facilities around the globe to ensure that we add features and technology into our products to enable sustainable design decisions to be made earlier in the process. So take, for example, 2D, 3D, or digital design software that allows you, as you're building or designing a piece of architecture, a building, if you're designing something mechanical, how do you ensure that you can do more digitally to visualize, to simulate, to analyze, to actually decide how a product works before it's ever produced? The more that you can do digitally and the more that you can do in the software to produce less prototypes, to produce less materials, to enable and ensure sustainable information is captured earlier in the design process, the better the end result will be. Less physical prototypes, less material, less energy, less waste. All these things allow us to be able to play in this arena of enabling sustainable design. The second key area that is part of the pillar of what Autodesk is we spend a tremendous amount of time communicating, not only in venues like this, but through our customers, again, 8 million legal customers around the globe. And our ability to communicate these critical issues to all of our customers helps us spread the general awareness in the world about sustainability design and the critical importance it has on everything we do. Thirdly, Autodesk as a company is committed as a global software vendor to be a sustainable company. So that has changed a lot of what we do inside of our company in terms of our principles. And fourth, through strategic partnerships, like the one that you're hearing about tonight with Control, events like this, sponsorships like this, the PBS series, wouldn't be possible without those types of strategic partnerships. So those are extremely critical for us. So the challenges that you're about to see, what's going to be presented tonight by global warming and kind of some of the things that are happening in the climate changes, these are all serious issues. And what I believe this series will do, what I believe some of this general awareness is doing, is it's beginning to socialize and allow these conversations to take place so that we now have forums to address them. We have places where we can talk about them. And more importantly, we have panels like the one you're going to hear from tonight, where discussions about viable solutions that weren't until recently allowed to be discussed can now happen. And that's really why sustainability and getting these messages out and getting more involved in sponsoring some of these events is critical from our viewpoint at Autodesk. So without further ado, I would now like to take the opportunity. It's my pleasure to introduce Karina Albers. Karina is the executive producer of the series. Karina?
Thank you. First, I would like to emphatically say that without the support of Autodesk, whose commitment to sustainability and to the future of design in the world that we live today, we wouldn't be here to be able to tell the stories that we are committed to telling. So first, I'd like to say that. Secondly, PBS has been a great partner for us, and being our broadcast partner for the release of this series has enabled us to be with a like-minded source that attracts the type of viewership where we feel we want to be telling our stories to people that will more than understand it, but will also be able to implement some of the solutions that we discuss. And we are storytellers first and foremost, and the stories we choose to tell are about the planet that we're living on today and all of the more or less stuff that is happening. So our commitment originally wasn't about global warming or climate change. It just happens that that is the world that we're living in currently. So that is what we chose to tell our stories about. We're not all about the problem, but we are all about the solution. And to have the thought leaders that we're able to interview for our series, we feel humbled and very, very privileged because they bring insight, intelligence, wisdom, and solutions, and probably most importantly, discourse. Discourse about what are our options, what can we be doing. And we feel that by being solutions-based storytellers, that we want to incite that. We want to incite discourse. We want people to talk about it. Our goal is not to paralyze people with fear, but to really talk about, hey, this is happening. What are we going to do? And we believe that by bringing this into the public domain, that's the energy that needs to be put against the problem so that we will be able to come up with the solutions. So thank you all for coming tonight. You're all a part of the solution, and I sincerely look forward to the discussion that will happen during the film and after. But just a little bit about E squared. I totally forgot. E squared stands for the economies of being environmentally conscious. And when we started to develop or conceive the idea of the story in 2002, it was all about the fact that now people were starting to pay attention to the environmental issues because it was becoming an economic issue as opposed to just an environmental issue. So when you get the markets working with you, then all of a sudden people pay much more attention. So we started the first series released on PBS in 2006, and it focused on design. And our goal is with E squared is to discuss 6 topics in 6 half-hour episodes. And again, to be able to interview and be very, very current, but at the same time evergreen about what we are discussing. So we want to be a little bit ahead of the curve, and I think we're able to do that because we feel that we've been involved for a bit of time, and now we see things being discussed that we're sort of like, yeah, we know that, so what's next? What's next? And we want to keep pushing it. want to keep pushing the envelope, and we want to keep having the discussions, and we want to keep interviewing those that are out there on the front line and are finding the solutions. So when we, Autodesk, again, sponsored the series in 2007, we're able to focus on not just design, but also on energy. And then moving forward, we'll be discussing in 2008 transportation, design, and then we'll also be looking at, once again, we'll be looking at energy. So there's many, many positive things happening. We want to focus on the positive. Again, thank you all for coming, and look forward to the discourse of the evening. And then on with the show.
So we did a little calculation. We're here to discuss the 363-kilo gorilla. Thank you all for coming tonight. Thank you to our sponsor, the Chamber of Commerce of Keene, New Hampshire. We have all the candidates here, Senator Clinton, Senator Obama, Mayor Giuliani. But wrong notes. We're here because the nuclear ducks are lining up in a row. A bunch of companies have found out it's possible to make good money running a reactor. They'd like to make more money running more reactors. That looks possible because of two of the big external factors that killed off reactors in the last round of construction now look better. They've shifted towards nuclear. They are that long-term interest rates are down, so it's now possible to consider a big long-term project. And the price of natural gas is very high. That's the main competing fuel in the last round. There's also an internal factor, which is people say they've gotten smarter about how to run a nuclear plant, and they think they've gotten smarter about how to build one. So right now there are 30 reactors on the drawing boards. There are 104 now running. The question isn't really if you're for or against nuclear power. The question is, what should the government be doing now to encourage or discourage the choice? That fits into the bigger question about how we're going to meet our energy and environmental needs. I'll start by throwing out a single data point. Last week, Lindblad, the tour agency, ordered 2 icebreakers/cruise ships for use in the Arctic Ocean in the summer. We've got an excellent panel to address the question. We have Nils Diaz, who was chairman of the Nuclear Regulatory Commission for part of the period when it changed its licensing procedure to try to lay the groundwork for a more rational regulatory process and construction process. Dan Kammen is a professor at Berkeley and an expert on how things are supposed to fit together: renewable energy, health and environment, impacts of electricity generation and use. Nuclear power does not exist in an energy vacuum. Ed Lyman is a nuclear physicist at the Union of Concerned Scientists and an expert on weapons, reactors and weapons and proliferation. Reactors can be used to make weapons, and lately nuclear energy can be a fig leaf for weapons production. And Mike Wallace is a specialist in starting up new reactors, and he's looking to make a comeback. He's even got some parts waiting in a warehouse. We're going to give each panelist 3 minutes for an opening statement. Then we'll go back through with 2-minute responses, and then I will take some questions. And we set up the order ahead of time by coin toss, but don't worry, we used hard currency. We used a euro. Dan Kammen will start, followed by Nils Diaz, Ed Lyman, and Mike Wallace. Dan?
Well, thanks very much, and thank you. That was a wonderful show. And I see I'm going to be a little more balanced. That was my cranky moments up there, I guess. I'm going to do just a little bit on where I see nuclear fitting in, and I think that the key question is one that Matt highlighted and Jeff Sachs did as well, and that's the incredibly obvious point that our energy future, as well as our present, has got to be a portfolio approach. Not that we know who is going to get what fraction of that pie, but that we're going to need all of these components in play, and we may choose to deploy some very largely and some very limited numbers, but we critically need an environment, political, financial, technological research, that allows us to have these technologies in the discussion. And for too long, our history has actually been one of not really doing that. Right now, the United States Department of Energy invests less in energy research than does the US pet food industry in its research base. And as valuable as your pets are, I think that most of us will agree that there's a little more pressing problems on this global warming, energy security, energy environmental justice fronts. And so we are critically underinvesting by every objective measure to have the basis to make some of those choices. In that environment, some technologies have flourished and some haven't got off the drawing board. And we don't really know which ones of those are going to help us to what amounts until we can really get that full conversation going. So right now, just a little under a quarter of the world's nuclear power plants, about 100 of them are in the United States, about 420 around the world. And so what we do in this area is critically important. The partnerships that we do between the federal government and scientists and engineers and the public in terms of what is the dialogue about what are the pros and cons, not just of nuclear, but all the technologies. What are the risks that we take on by building a wind farm that may affect birds, or a nuclear plant that has a certain risk of an accident, or what are the risks of the waste streams of any of these things? And the real dialogue that we have not yet opened up is a way to think about these things in a framework that allows you to make what I would call apples-to-apples choices. And what's interesting is that if you hear people talk about nuclear in particular, it's as if you're talking about two different technologies. The people who are strongly pro-nuclear point to the same data set and say, clearly we should build many more of these. And people who are anti-nuclear point to the same data and say, clearly we shouldn't build more of these. And that's actually not a healthy dialogue for any of us. What's clearly a better position is if we had data and a conversation that we may differ on quite significantly, but that the prospects for the future, whether it's the pebble bed plants you saw here, or some of the pressurized water reactors, sort of a near-term option, some of the liquid metal, there's a whole variety of technologies out there, including some we actually haven't pursued at all. There are, in fact, reactors that would burn thorium that, in fact, don't have the proliferation problems, but are ones that we chose financially or politically not to explore. And so really part of what I think the critical moment we're in now is to find a way to make this a dialogue about technology. So some people will say nuclear is the cheapest form of energy because the cost of the bus bar, the so-called electricity cost out of the plant, is the absolute cheapest. And some people look at the whole cradle-to-grave cycle with storage, with work on Yucca Mountain and other type facilities, and they say it's still the cheapest. Others look at that price tag and they say, well, you're not taking my risks into account. You're not taking my view of what the full life cycle is. And this is actually a very unhealthy point to be at from all perspectives, whether you're pro-nuclear or anti-nuclear or want to figure out what we might do to be more rational about all these choices. And unfortunately right now, that dialogue is not really active. There are strong positions across the spectrum, but there isn't a really comprehensive dialogue for one reason, and we'll talk about this one tonight certainly, that different people's views on what the costs are quite variable. And then we get into the risk issues and the proliferation issues, and we have a very complex situation. And I personally will throw one out right off, and that is there's no question in my mind that I would rather have a nuclear power plant built in my backyard than a coal plant. It's not even a question from my perspective. But the full life cycle of these technologies are ones that make that story much more complicated, and one that we have not got a good dialogue around. And so we'll come back to many of these points, but in terms of laying out what I think the moment we're at right now is, can we have a dialogue where all these technologies, nuclear, sequestration, solar, renewables, biofuels, are all on an even playing field so that we can figure out what we want and not just build what is the path of least resistance for any given one. So I look forward to your questions as we go.
Thank you. Nils? Thank you, Matt. I agree, and of course I disagree in a couple of points. You wouldn't.
Of course.
Let me see how I can follow the train of thoughts. I do believe that we need a portfolio. That's a word I've been using for many years, and there is no doubt that that's where some of the problems are. Having that said, and having spent so many years of my life making nuclear power safe, reliable, and secure, I think I'm going to take that same tack. Sometimes you cannot teach an old dog new tricks. So let me go ahead and try to focus on that. Nuclear, power electrical generation can continue and should increasingly help to maintain and enhance the environment, regionally and globally. The benefits of clean, reliable, user-friendly electrical energy is found by all of us in every aspect of modern life. Its uses, however, can grow and expand to other areas where the beneficial environmental aspects of electrical energy can be put to play. Key case is transportation. The generation of electricity needs to be diversified. There is no doubt about it. We need to diversify it in order to balance the dominant role of carbon-emitting generators, as well as to decrease price volatility, which we all have experienced and could be actually a tremendous impact on the economy. In the United States specifically, diversification can be achieved by the addition of nuclear power, wind power, and other renewables. Nuclear power generation specifically has strategic and energy security advantages for the United States and for other countries, including the fuel diversity aspect, independence from the fossil fuel marketplace, reliability of fuel supply, and stable operating costs with price forwarding stability. Nuclear power is actually an anti-inflationary technology. It costs a lot to build it at the beginning, but then the price remains very, very stable. The sustained safety, security, and generation reliability of the current fleet of light water reactors in the United States and other countries, coupled with the enhancements made to and for the design, construction, and operational safety of advanced standard reactors, are enabling factors for the addition of new power plants to the United States grid. They would be licensed and regulated by a significantly improved framework already in place by the United States Nuclear Regulatory Commission, my former employee, committed to the protection of public health and safety and the protection of the environment. New reactors, the ones that will probably be built, are safer, simpler, easier to operate and to maintain. Nuclear electrical generators have high capital costs and become economically competitive by their low marginal or production costs, based on very low fuel costs and high capacity factors. NRC's change licensing process, which involves a combined construction and operating licensing framework, as enacted by the Congress of the United States, has vastly improved licensing processes. Provides a comprehensive safety evaluation prior to the construction of commencement. And that's a very key issue. Prior to you starting the construction, you have had your safety analysis done, and if appropriate, you will get a license. This limits financial risk, puts it at the front end before utilities make the major investments, and it enables better and early decision making by all involved. The combination of convergent factors favorable to nuclear power deployment now includes the full set of environmental considerations, topped by its no carbon burden operation. Nuclear power plants, like all plants, need fuel and they need a plant to be able to operate and function. Nuclear power plants do not discharge its used fuel into the environment. It is securely kept, stored, and away from the environment, okay, as long as is needed. I will welcome the discussion that will surely come on the always emotional issue of disposition of used fuel, also called the waste disposal issue. It is an important socio-political issue, and it does require resolution. It is not, however, linked to new nuclear power plant deployment on a one-to-one basis now. Used fuel is now and can be safely and securely stored without environmental impact for up to 100 years. Its disposition will be resolved long before that time. To conclude, I believe that large capacity, fission power electricity generation without carbon or pollutant emissions should be added to energy portfolios for security and long-term economics of electrical supply, and yes, for environmental reasons. Thank you.
In any good debate, one of the participants is scribbling furiously while the next talks. So, Ed,
That's right.
you're up.
Thanks, Matt. Is this working? The organization I represent, Union of Concerned Scientists, does recognize the threat posed by global climate change, and that is one of our top priorities, is addressing that threat. However, we historically have been skeptics of nuclear power dating back to the founding of the organization in the late 1960s. And in the absence of the kind of apples-to-apples comparison that Dan talked about, and that I think would also be a great idea, but really very difficult to implement, because how do you try to quantitatively compare the risks associated with climate change with the different pattern of risks associated with nuclear power? It's very hard to do. So in the absence of that kind of analysis, we believe that you don't throw the baby out with the bathwater. You acknowledge climate change as a risk, but you cannot dismiss the very real risks associated with nuclear power that have not yet been resolved, and that until there's a better sense of how they're going to be resolved, we can't support a large expansion of nuclear power. And these risks Jeffrey Sachs alluded to, really the four horsemen, are safety, security, nuclear waste disposal, and nuclear proliferation. Now, on the issue of safety, I'm a little less sanguine than Jeffrey or Dan on the threat, the safety threat posed by nuclear reactors and the potential for severe accidents that could lead to a Chernobyl-style core melt and radiation release. And anyone who wants to be graphically appreciate what a large release of cesium from the core of a nuclear reactor can do, I would urge you to visit the villages around the Chernobyl site like I did last year. Just based on industry's own calculations, the risk in the United States of a core melt accident over the entire fleet of about 100 reactors is about 1% per year. So you can't really say or imagine a great increase in the population of nuclear power plants without doing something to address that individual risk. And despite what Nils said, it's not the policy of the Nuclear Regulatory Commission to require that new nuclear reactors be substantially safer than the current generation. And the reason for that is that if the NRC were to acknowledge that new reactors should be safer, that would cast some doubt about the safety of the current generation. They don't want to do that. So that policy is really leading to status quo, and we don't think that that's a good policy for the U.S. to pursue as we talk about a nuclear renaissance. With the issue of security, in the aftermath of September 11th, we know that U.S. critical infrastructure is at risk and continues to be at risk, and the Nuclear Regulatory Commission has not adequately addressed that risk in our view. And the risk is that no matter how safe a nuclear reactor may be on paper, if there's a dedicated team of saboteurs who knows what to do, they can cause a very severe event, which, if you left it up to chance, would only happen once in 10,000 years or so. So the only way to compensate for that is through guns, guards, and gates. And even today, 6 years after the September 11th attack, security is sorely lacking. You only need to see what was broadcast on Channel 2 News in New York a few weeks ago, a film surreptitiously taken of sleeping security guards at the Peach Bottom plant in Pennsylvania, not that far from here. It turns out they had one of the teams of security guards had a conspiracy going where they would let the others nap while one would keep watch. And the NRC, even though they received an allegation about this back in March of this year, didn't respond until this film was broadcast on CBS News. And that isn't the kind of response that we think is appropriate and will justify an expansion of nuclear power in the face of the terrorist threat. With regard to the waste issue, we agree that nuclear fuel, if it's properly stored and secured, is not the greatest environmental threat in the short term. But it does have a long shelf life, as everyone can appreciate, unless our generation takes the steps to make sure that that waste does not pose a threat over the entire lifetime over which it can pose a threat, then we're not fulfilling our responsibility to future generations. And the fact is that despite decades of attempts our country is really hardly closer to finding a long-term repository for this waste than they were 20 years ago. And so without a credible long-term storage strategy for nuclear waste, it's hard to justify generating large additional quantities of this material. Finally, with regard to proliferation, the two-edged sword of nuclear power is the facilities that can be used to make fuel or electric power can also be perverted to make the materials for nuclear weapons. And as nuclear power expands in the world, the ability of the international community to control those facilities and safeguard them so that they are not abused in that way to produce nuclear weapons materials is becoming a greater and greater challenge. And in view of the situation today in countries like Iran and elsewhere, it's still not at all clear that that challenge can be met successfully. So with that, those are some of the problems that we see that lead us to question whether or not the world is ready for a large-scale expansion of nuclear power. Thank you.
Thank you. And Mike, what was that old car commercial, Ask the Man Who Owns One?
Yeah, I guess that's probably right. I'm perhaps the practitioner among the panel here. And I guess the good news as I'm listening to Ed is I only disagree with about 80% of what he says. So we'll have a good basis for dialogue here. But truly, my role, as I take it here, is to stick with a fact-based perspective on nuclear and new nuclear and what's really involved. The practitioner side comes from the fact that I had responsibilities for building 4 nuclear units in the 80s. In Illinois, all successfully completed, and they're among the best operating nuclear plants today. My company, Constellation Energy, just by perspective, is the largest wholesale provider of electricity in the country. We operate in all the open markets and competitive states. We generate electricity absolutely every way you can, except we don't have any wind power at the present time, but we have geothermal, solar, waste coal, gas, oil, and nuclear. 2/3 of the energy we generate come from the 5 nuclear units that we have today. So our company understands how to generate electricity in every way that you can do it. We are a fully competitive company, so there's no rate base subsidy to what we're doing. So we need to make market-based judgments about how we're going to provide energy solutions. And when we do that, we don't look at the, if you will, more research-oriented, what could be, what might be, what should be. We need a demo, it's here, it's there. We look at what is. And our job, as we take it very responsibly, is to keep the lights on and look at the supply-demand forces, and therefore what will be necessary in what period of time to produce additional electricity to keep the lights on. As we look at that in the past several years, we see the very growing momentum for environmental responsibility and climate change, strong market force. And we see a very growing market force for energy independence and energy security for obvious reasons. Those forces are being manifested in economic drivers that incent us to do what the market, the public, and the politicians through lawmaking are telling us is the right solution today for tomorrow. And when we look at what's available today, we look at coal plants. We won't build any coal plants. We've made the judgment that is just not where the confluence of forces are suggesting we should be as we go forward into the future. The costs are too high, the risks are too high, the environmental issues are troubling. We don't know what carbon sequestration could even look like. It's technologically unproven. We don't know what the economics are, and what it just costs to make electricity out of coal, not counting CO2, is very expensive today. So that option is sort of ticked off and gone. Second major option we look at is the so-called clean coal technologies, IGCC referred to in the video, with carbon sequestration, future gen, great idea, not here today. Maybe it will be in 20 years, not here today. Third we get to is gas. Gas plants are all over the place. Easy to build, fairly economical, they produce CO2, but as we all are seeing, the prices of natural gas just continue to rise. We're moving in a direction where we're going to be dependent on gas from foreign sources, just as we are today dependent on oil to drive our cars. So where is that really taking us? And it doesn't fully address the CO2 solution. So we look at nuclear power, and we are not nuclear zealots. We are not nuclear advocates. We are businessmen that make a risk-informed judgment about, given the solutions available today, what should we do to responsibly keep the lights on reliably and try to curb the cost increases, if not bring the cost down. Nuclear plants are being built all over the world. We haven't done it in this country in 25 years. France has continued to build them, Japan, Korea, Taiwan, other places in the world, secure Western countries, have been successfully building nuclear power plants. Of course, it is a very, very important technology to focus on from a safety and security point of view. So to just hit those issues, and then in closing, we're down a path, Constellation Energy, partnered with Areva in France and EDF in France. EDF has 58 operating nuclear power plants, providing 80% of the electricity in France. France is the greenest economy in all of Europe, period. And those guys are partnered with us to help us build the kind of power plant here that they're actually building in France today as we speak, their newest power plant, so-called EPR. That plant is the safest plant in the world. And that's safe on the basis of quantitative metrics, not just a subjective verb. It is the most secure power plant in the world. Literally, it has a double containment, a box around a box. Or as one person put it, nothing inside the box gets out and nothing outside the box gets in. It is absolutely impervious to attack by terrorists. And in the safety area, the redundancy is quadruple, 4 times what we need in safety trains. Now, it's an expensive plant. So then we come to the 2 issues that are the ones we focus on the most right now. One, the NRC licensing process, which Nils referred to, that both he and I, at different times in our career, helped to refashion the way that it is to work better in the U.S. We believe will work, but it's never been tested. So there is risk in how that process will actually work, number one. Number 2 is financing. As I think somebody said in the tape, there's not a bank that will lend us the money to build this plant because there's no track record in the U.S. since it hasn't been done for 25 years. So that's why the Energy Policy Act provided incentives for a limited period of time to help with some of the financial risks just to get the first ones built, and then they have to stand on their own feet. No subsidies long term are needed or should be needed. These plants should stand on their own. So we're convinced that new nuclear plants are the way to provide safe, secure, environmentally responsible energy in the future. We can build them safely, we can operate them safely, we can build them economically. We need some assistance to deal with these risks because we haven't done it in 25 years. Thanks.
And I was afraid we wouldn't have anything to talk about. We're going to go to the line again and give each panelist 2 minutes to respond to what the other panelists have said, and then we'll take some questions. Dan?
Well, I think actually what I want to do is I'd like to add 2 additional points, and I'll do one comment which is nominally pro-nuclear and one nominally anti to kind of balance things a bit. And that is that one of the interesting things to think about, one of the really challenging things, is the calculus of nuclear as a climate change protection strategy is actually a little bit tricky. And the following is how I would frame that. We currently have 20% of our power from nuclear plants, as you heard on the film. And all of those plants are going to come to the end of their operational life in the next several decades. That means just to keep status quo of the number of plants, not the percentage of power, because our demand for power is increasing, we would need to build 100 plants over the next several decades. If nuclear is to increase in its share, or even sort of hold pace as the percentage, as our overall demand rises, everyone's calculus may differ, but you'd probably have to build an additional 100 to 200 plants. And in my calculus, if we really wanted nuclear to be a significantly larger fraction of that mix, we probably have to build the 100 replacement plants plus 100 to 200 more, almost 300 plants over the next 30 to 50 years. Over 30 years, that would be basically 1 plant a month or 10 plants a year for the next 3 decades. And one key thing to put in mind here is, do we think we have the ability to ramp up to that? Not just politically, but in terms of the capacity to build that amount of plants. And in my mind, that's a very, very open question. It's one that many experts think we are not anywhere near the capacity, both human and technological, to do that, even if we decided that was our strategy, and even before we get to the management of all the waste. So that's sort of a mildly negative one. Let me give one mildly positive one. That was, we haven't talked about, for obvious reasons, transportation. Transportation is expected to be the dominant use of liquid fuels in the coming decades, and over half of our oil will go to transportation decades from now. Nuclear actually has an interesting and important role to play there, because among the various routes to make liquid fuels, off-peak nuclear power to charge up plug-in hybrid vehicles, nuclear power to provide the energy source to make biofuels, or one that worries me, to make liquid fuels from coal, are all things that nuclear can do without adding more carbon to the process. And many of the ways that we would get those liquid fuels down the line are ones where nuclear could play a remarkably important role. So I actually see a confluence of the so-called new renewables and nuclear as a way to think about plug-in hybrid vehicles and liquid fuels, including ethanol, with much less carbon required to make it. So there's all kinds of interesting things that begin to cross the old divide of stationary power and mobile power that many analysts and many politicians have not thought about, because nuclear was always thought of as a purely stationary power option. It actually has opportunities to play a significant role in low-carbon transportation as well.
Yes, thank you. Yeah, I thought I was politically inclined, but Dan, that was very good. Taking both sides. Let me go to 2 things that Dan says. I'm going to go very quickly to some of the points, because I think they are worthwhile responding. Dan actually, in his first presentation, emphasized something that it's very dear to my heart. I was a professor for 31 years. I did research, applied research, but once I left the academia, I realized that we need a mixture of research and application. And when you have a problem, you cannot just continue to do research. You need to find out what works, and you need to put that to work and then continue to do the research. Second issue is the issue of, and this is going to show how old I am, there was a part in my life in which I have left the university. I was working, I had 6 small companies that actually did reactor startups, all kinds of those things. At that time, either being built at the same time, broken ground or done, there were 126 nuclear power plants at the same time. Okay, to give you an idea of the misconceptions that exist, there are 104 nuclear power plants operating today. 54 of those were built before 1979, before 3 Mile Island, and 50 were built after 3 Mile Islands. The ones that were built before 3 Mile Islands were built in 5.4 years, and most of them at very reasonable cost. The ones that were built after 3 Mile Island were built in 11.8 years at enormous cost, not only because 3 Mile Island, but because of inflation, interest, economics, problems, and so forth. I do believe the United States of America has the capability to do what we did when we didn't have a computer-aided design or any of the things that are presently existent to help us find the right supply chain, have the designs done, and so forth. Ed and I have known each other for many years, and we have agreed at times and disagreed at times. He used some figures that I just can't let it by. He says the accident rate is 1% per year. Well, that doesn't match with history. We have almost 3,500 reactor years, 3,500 reactor years, there's been one accident. So historically, the numbers are wrong. Number two, if you really look at the real numbers that we have today with what is done, the potential probabilistic rate is close to 1 × 10⁻⁴, or 1 in 10,000 years. Ed referred to the fact that reactors are not required to be safer. Technically, he's right. In this democracy, the NRC decided we could not impose that criteria. However, we did it. It didn't matter whether we ordered it or not. It was done. Present reactors are at least an order of magnitude safer. Measured in the labs with tests done with taking the technology and incorporating what we know by improving the material. So the new generation of reactors is safer and more secure than before. The issue that the issue of fuel storage and the strategy. Well, the reality is that we will have, this country will have a fuel disposition strategy, certainly, hopefully within our lifetimes, and it's going to be much better. No country in the world known has actually developed a geologic repository or any way of storing, the fuel. And the reason is that people have always been waiting to develop a better alternative, and because there was no reason for it. Furthermore, no civilian reactor as power reactor has contributed to proliferation. Ever, never. Not one reactor in the history of the world that is a civilian reactor has been used to make weapons. Research reactors have been used to make weapons. Reactors that were made to make weapons, like Chernobyl, which was a dual-use reactors, were made to make weapons, but no civilian reactor has ever been turned into a weapon-making machine. None whatsoever, never. The nuclear proliferation issue is an important issue, one that we should all be concerned with, one that Ed and I have worked around. I think it's one that should be served by a global approach to what the world needs as energy and how we can actually prevent proliferation. And I believe that that is doable.
Okay. I thought I would disarm Mike by saying that I agreed with you and that we do concur that the EPR is probably one of the safest light water reactor designs out there. But I hope you'll also agree with me that that's not because you designed it to meet NRC standards, but it was designed to meet European standards, which were higher. And in fact, we worry that if it turns out the EPR's costs are too prohibitive, that you're going to strip down some of those additional safety features. So we'd urge you not to do that. But you're right, it is expensive, and you did forget to mention the first EPR, which is actually being constructed in Finland, and which has experienced considerable cost overruns and delays, which might be expected for first of a kind, but also I think, have some troubling implications. It's already, I think, going to be 50% over budget, and it's a couple of years late at least. The issue of cost, you did say that your approach is market-based, and what I hear a paradox, and that on the one hand, the nuclear industry is saying nuclear power is the only really reliable, large baseload, carbon-free energy source that this is what you can put all your trust in and have confidence in. And on the other side, you're going to the federal government and saying, it's really an innovative technology, we've really lost the industrial base, we forgot how to do it, we need loan guarantees to prop us up so that you don't need to go to the federal government and get loan guarantees for 80% of the which is really doesn't give me any much more confidence as a large-scale carbon mitigation source than a lot of the renewable options. So that's my observation. And finally, on the issue of proliferation, it's not the diversion of commercial reactors that's the largest concern, but it's the production of fuel, in particular uranium enrichment plants, and whether or not a country that develops indigenous technology to enrich uranium for power reactors can use that same technology, pervert it, and actually enrich uranium to the higher concentration needed to make weapons. And that's the latent proliferation problem that we're struggling with in Iran. And although many analysts say very glibly that there's some, we can rely on some international structure in which the plants that make uranium fuel will be controlled by a small number of countries and supply fuel to others that will then forswear their right to operate or to develop their own indigenous facilities. There's absolutely no evidence right now that those kind of international structures have any chance of succeeding, mainly because those countries that are the targets of that kind of a structure, like Iran, we've made offers to Iran that will provide them with guaranteed fuel assurances if they give up their own uranium enrichment activities, and they've rebuffed that offer. So there's really no confidence that that kind of structure is going to be is a basis for building the international system for a large-scale expansion of nuclear power.
Mike?
Anchorman, last time. Ed, you're helping to make my case, and I appreciate that. Your comment was that the EPR, the plant that we're building, has safety and security margins above what are the NRC's minimums. That is a fact. The regulatory standards don't require us to do exactly what we're doing. So why would my company, a fully competitive company, no subsidy for our costs at all, be building something in excess of minimum regulatory requirements? One simple reason. That's how we get the safest, most secure, most reliable plant. And that's good business. So when this plant is built, it is the safest. It isn't going to have any sort of problems of any sort. It is the most secure. Terrorists are not going to be able to impact it. It is the most reliable because it's an evolutionary technology, not a far change from what we've done in the past. Now, the knock that the plant we have, to be fair, and Ed's hit on it a bit, it is a big plant. It has a lot of concrete and steel. And there's a project management challenge just building that big of a facility. Now, the plant in Finland is above the Arctic Circle. On December 21st, there's only 4 hours of daylight. They have a population in Finland of 6 million people. They're importing workers from 28 countries. And the poor guys from Poland don't read the English, so they have a plethora of issues trying to get work done in this very, very difficult environment. Thankfully, the second one like that that's being built is being built in the northeast of France, northwest of France. The climate is a whole lot more friendly, and it's all being done in French and English. It's the same plant, but being built by EDF. They built 58 others, most recently in 0102. They know how to build big power plants. Some of their people and all of their data is what's coming into the plant that we're building. We're building this because it is above the minimum, and it'll give us the most reliable plant operating 60 years and beyond. That's point one. Point two, your question on loan guarantees. Good question. Why do we need loan guarantees if this is not a brand new technology? This is not a brand new technology. It's nuclear power plants. We understand them. This one is not a big change from the last ones we built here. So what do we need loan guarantees for? Because we haven't built one in this country in 25 years, and the regulatory licensing process to do it is untested. And the bank does not want to lend us the money, think of building a house, to build the house and take on the risk that we get it half done and we can't get an occupancy permit to move into the house. The bank doesn't want that risk. Now, if 4 houses were already built on the street, then the bank would go in and say, well, look, 4 of them got occupancy permits. I don't need any help. We'll finance your 5th house. That's exactly where we are in nuclear power. We need to get it moving down the path. last, maybe it'll be a surprising comment I'll make to one of Dan's comments, and that is we need 200 to 300 over the 30 to 50 years. Totally agree with that. That's what we need. And he said the question is open as to whether we have the capacity to do that. Well, to me, the question's not open. We can't do it. Period. Today. We cannot do it. We are going to be subservient to the global supply chain for new nuclear here. When I built 4 units in the 80s, everything in those plants came from the U.S. Everything came from the U.S. Steel, controls, wires, cables, everything. Today, 80%'s got to come from offshore because we don't make it here. And that's where the Chinese are going, the Russians are going, the Japanese are going, the French are going. They're all going to those same global supply places, and they can't be expanded in anything less than about a decade to get to production size scale. So Dan's right on of what we should do, but I would say there is a practical reason why it won't happen. So the technology is there, it's proven, the help is needed to get 4 houses built on the street so we can have confidence that the 5th through 20th will be built as well.
Okay, to summarize and tie this all together, the reason the French design is the most secure, you may have missed this, is because if they catch the terrorists, they make them do French irregular verb conjugation.
It's the Finnish verbs that are really tricky.
Verbs, right?
Finnish verbs that are really hard.
We have, just like Oprah, we have runners with microphones, and I would ask, when you ask questions, stand up and identify yourself and make it a question. And this gentleman here, in green on the left.
My name is Jeff Hayes. I'm nobody, just interested citizen.
Good.
I would like the panelists, in particular, sorry I forgot your name.
Mike Wallace.
And Ed, perhaps, to address sort of one of the points from the movie, which was about sort of distributed small-scale nuclear energy, sort of the, I guess these are sort of speculative designs that they're still working on, but it seems like there's such a battle royale going on in terms of just sort of building one of these huge nuclear power plants, that I'm wondering what it would do to the debate in terms of actually enabling nuclear to become a part of the portfolio that you were talking about. Because right now, we can talk about it all we want, but there just seems to be this array of forces which is, preventing, anything from getting done. So what if you took it down to a much smaller scale, and then, would you still have a huge problem with that, Ed? Or, would that make things easier? Would that make the political debate easier or harder? If you could just talk about that.
Okay, maybe let me give a quick answer, and then I'll turn it to Ed. The plants that we're seeking to build, we're actually down the process right now. Matt mentioned we have hardware. We bought the forgings. They're sitting on the shop floor at Japan Steelworks. That's about $50 million worth of hardware. We're doing the design. We have 600 engineers in the U.S. working on this plant right now full-time. We're doing all the work to get down the path, put in the license. At some point, we're going to come to a pause if we can't see that the bank is going to be able to give us the loan. So we're moving, we're not waiting, and what we're building is being built elsewhere in the world. To what you saw in the movie, Pebble Bed Reactor was the one with the black balls. Great concept. I really like the idea, but it's not here today. Maybe it's here in 10 years or 20 or 50. I've been in this business 38 years, and when I first came in, fusion was just a little bit away. And today, fusion hasn't gotten any closer than it was 38 years ago. So maybe Pebble Bed works great, but I don't know that. And as a practitioner, I've got to deploy solutions that will work today. And even at that, going as fast as I'm going, and I've been at this now 3 years, my company has, to build a new nuclear plant, it can't come online if everything works great sooner than 2015 for the first one, because the first ones are going to take so long. So we're way behind the curve now. We got to work with what's already a proven technology.
My view on whether nuclear power is appropriate for distributed generation, I actually don't think so. I think it's really appropriate for large centralized baseload because, for instance, take into account the security issues. It's a lot harder to protect a large number of small reactors scattered around the countryside than it is to protect one large centralized site. So, and some of the, if we're going to favor nuclear energy, it would really be a smaller number of sites with better protection each one. Now, if you're talking about modular additions to a single site so that you're just expanding capacity to meet demand, I'm not sure if there's that great advantage. And if you're talking about one site with 10 small reactors instead of one large one, then that does introduce a number of headaches with regard to operation, protection of the reactor site. So I'm not sure there's really that great advantage there. With regard to the pebble bed, again, it's a speculative technology. There are trade-offs. It's safer in some respects, but it's more dangerous in others. For instance, Professor Kadak didn't mention that if any air gets into the reactor core at all, the fuel can catch fire because hot graphite will ignite and possibly burn autocatalytically, which means you've got a fire that you can't put out with water. So that presents problems. So there are a lot of safety issues. There's really no panacea.
I should say that in the 90s, Westinghouse decided the reason nobody was buying its reactors was they were too big. So it went to the trouble of designing and having certified the AP 600, Advanced Passive 600 megawatts, and nobody bought that either after they spent a great deal of money on it. So they went out and they designed the AP 1000, which, as the name implies, is 1150 megawatts, and they're now hoping to sell one of those. But Dr. Diaz, you have a special spot in your heart for the pebble bed, and why don't we give you an opportunity to respond?
I really don't. No, I really believe that it offers potential inherent safety features, but it is not here. The fuel has not been tested long enough. The technology appears promising, but certainly I don't expect it to have an impact in this country in the next 25 years. It will take that long to develop a program that will prove the technology.
Dan?
Just a very quick point on the pebble bed. Its safety was inherent in the picture. There is no physical core. There is no thing like the elephant's foot that melted through the core in Chernobyl, this huge pile of fuel down below, because when the power goes off, those softballs just simply scatter around. And so there's this inherently interesting feature about it. But I think what you're hearing in the disinterest in this design is that nuclear inherently is large, centralized, and plants that have this smaller modular feature might sound good if you talk about a distributed grid, but in fact, the inherent way you would manage nuclear plants is probably to put big facilities where we currently have nuclear plants. Our 104 plants are at 67 sites around the country. Almost everyone, I believe, thinks the next set of big building will go on largely, although not 100%, at those sites. You've already got a secure fence line, you've got a track record, you've got stuff going on that allow, this is our nuclear power park. It's unlikely that dividing the already overstretched nuclear workforce to spend a huge amount of effort on this one, the pebble bed, while trying to build out these quite safe, this French design, is likely a way that I think the industry would portion up its human capital, which in the end is the really critical feature to do a lot of this sort of work.
Next year we'll get Andy Kadak down here to defend himself.
Yes, right.
Yes, over here.
Hello, my name is Jan Mueller, and I'm here on behalf of the Environmental and Energy Study Institute. But I am agnostic on nuclear energy. But the thing about a dialogue, I think, is hard to agree on the crux question that you're trying to frame. And I guess the title of tonight's was Can Nuclear Help Save the Environment? And just purely from, we talked about how we can't compare risks apples to apples. So just in terms of climate change, the question that I guess I'm hoping to get some answer on is putting these things in terms of trade-offs. And I think you can't really have this conversation unless there's not enough numerical, quantitative context to this. And I think there was an interesting figure from the film, one nuclear power plant, 10,000 windmills. So if the question is not, are nuclear power plants safer than they have been? They may be, but that's not the question I'm looking for. Is it better Dan said would rather have a coal or nuclear in his power plant. Maybe that's the first question. Let's say we choose nuclear. What's the next? I guess the next question. So is if we can provide, you will come down as being pro-nuclear if you think we cannot substitute something else for nuclear. You'll come down as being anti-nuclear if you continue to believe that we'll build 10,000 or more power plants for every, or we're going to curb demand. So I guess I'd like to hear people address that question, if possible.
And I'd like to throw in one other idea here, which is Jan's question would be a lot easier to answer if we had an implied price of carbon dioxide. Okay. What would carbon dioxide have to cost to make it worth going to use a technical term, the fuss and bother of building a reactor?
Okay, so there's a lot tied into these things. Let me do the easier parts first, because that's always the way to cheat on the hard parts. And that is that even a relatively low price for carbon, and whether we have a cap and trade system like in the Lieberman-Warner bill, or whether we have a carbon tax, depending where you think we're going to go, they imply prices of carbon, either a direct thing you pay or a shadow price. That's the price of this carbon, the permits in the market. At even a low price, $20 a ton of carbon or some number on the low end, and people talk to numbers up a couple $100s as well on the very high end, nuclear works in the sense that stationary power, it's much easier to impact. And a relatively low price of carbon already would change people's feeling about which technologies to deploy. And the reason for that is that our stationary power is much cheaper for us than vehicle power. And so a low price of carbon even would have an impact on building new nuclear plants. It's harder to deal in the vehicle world, where even a very high price of carbon might not change our behavior because most of us demonstrate our ability to drive no matter what the price of gasoline does. So at one level, nuclear can certainly fit in even under a very, very low carbon price regime. The other point, though, about the 10,000 windmills or the nuclear power plant, I actually think we critically are going to need some combination of both. And we're likely to need all of these things, even the one I was quite disparaging about, the carbon capture in the film, largely because that's one I believe that the private sector, if it wanted to, could build today and could demo itself. Whereas there are some of these real barriers to getting the next nuclear power plant built. The joke is everyone wants to build the second plant. No one wants to build the first plant, where all the risks and all the cost numbers come true. But if we haven't done it in several decades, we are going to need to get through this hump that Mike talked about. And so getting those guarantees, while some of us think they might be a little bit too large, is a critical thing to have on the agenda. When I started grad school, I was told by faculty members of all kinds of political persuasions that solar will never be more than a total bit market, less than 1%. And the same is true for wind. And we now have parts of the world where wind is a significant player. There are parts of Germany where wind provides 25% of electricity on the average month and peaks at 50. 20 years ago, I was told explicitly that was impossible. The grid would blow up, would become communist, do all kinds of crazy things. It wouldn't happen. That, to my mind, is the real answer to the question. If you think all of these can play in a low-carbon world, then I think we need to explore them. And certainly, the new renewable solar, wind, biofuels have a role here. I see nuclear having a role here. I believe we're going to do carbon capture. But we've got to open up the markets. And right now, it's very hard for new things to get into the market. The easiest thing to do is to build more of what we know how to do, coal, oil plants, gas. And the next easiest thing is to do what we know how to do plus a trivial change. Not a trivial change, but a change which is not intellectually hard. Saying we're going to capture carbon and then finding out if we actually can do it or not. So to my mind, these new entrants, and nuclear fits in this area, is a new entrant if you want to talk about a new, safer version. So we're going to need to get those scaled up. But they all have a big role, and it's not a 10,000 wind or nuclear. We're going to need a lot of these, because remember, our goal is at least an 80% cut in carbon over the next 4+ decades. That's a huge, world-changing goal to need. We've never tried it before.
So do I need to explain, just so we don't lose the audience, what it was communists were?
Those communists were weird things that happened in the grid that did strange things in Germany and elsewhere when the renewables got a large share in the grid.
That's right.
So.
Please.
Let me just add We use the word portfolio several times, and you have seen it many times in the press. And actually, it is not as simple as it looks. A good portfolio is that one in which one component supports the other, rather than being combatants or being against each other. So when we talk about a diversified energy portfolio, we are trying to put together the best that each one of these technology has to offer. Because, for example, windmills only operate part of the time. And although we want it and we like it, you're going to have something that if the wind is not blowing at that time and you're turning your lights on or the factory is going to work, it has to be there. On the other hand, we are learning more and more how to distribute load, which is another part of the equation. So the way of distributing the load, maximizing your assets, all of those things come to play. And when you talk about energy portfolio diversification, we are saying what fits this country, what fits this region, and how do we make it all work together. And that's something that is very needed. We have not gone to the point where we can forecast where do we going to need what power when, and therefore a diversified portfolio is extremely important.
Ed? Yeah, I'd just like to throw one other thing out there, and that's if nuclear energy is going to really be a significant player in carbon mitigation, you have to consider the international aspects and where is the greatest growth in energy projected to be in countries like China. Now, China is industrializing very rapidly, but I think there's evidence that its own regulatory system is still flawed in many respects. For one thing, it can't keep lead out of children's toys it exports. It can't protect coal miners. They're back in the 19th century with regard to a lot of industrial safety and health requirements. So can we responsibly advocate for large-scale growth of nuclear energy in China without the confidence that they have a regulatory system in place that's actually going to be able to build and operate nuclear plants with, if we can't do it here too well, and I can give you plenty of evidence for that, we're going to need, in order to make this work globally, we're going to need global standards. And that is something that the nuclear industry internationally has fought tooth and nail, because no country wants to be told what to do by some international organization. And there's a nuclear safety convention which has no teeth in it. It doesn't allow international inspectors to actually do anything except complain about the situation in the country, and everything's secret. The public can't see it anyway. So until there's that kind of structure in place, I'm very concerned about proposals to greatly expand nuclear energy in the developing world.
I'd just like to comment on that point. The old adage is the way to lead is to lead. And you can't lead if you don't step out. And frankly, the Nuclear Regulatory Commission, and as you know, Nils Diaz was chairman of that, and so he was my regulator. I'm very proud of the fact that the Nuclear Regulatory Commission is a very tough regulator. They're not easy. But by doing that, they have set a tough standard, and the NRC is the standard that other responsible countries are emulating. Now, I can't say that about all countries. I don't know how to characterize China, and I don't want to get into a political issue, but I can tell you the most responsible Western countries are looking to the NRC as the role model for how to be a tough regulator. And actually, it was Nils who started the initiative with several other Western regulators to begin creating a global standard based upon the U.S. leadership. But if we're not building nuclear plants here, how can we be telling somebody someplace else how they ought to do it? And if we do it here and we do it right, then we set the standard for others to follow.
I would observe that your industry and Greenpeace have come to agreement on one point, which is a nuclear accident anywhere is a nuclear accident everywhere. And we have time for about one more question. Over here.
I'm Douglas Cobb, and I'm half engineer and half economist. The engineer is positive and optimistic. The economist is negative and pessimistic. I'm also zero politician. But I think we're missing a lot of points here because there is nobody putting the political scene into this discussion. And until we have political leadership, we're not going to get anywhere with all of your fondest dreams. Dan, you started off by saying that we were spending more money on research for pet food. I don't think that's amazing. I think that 80 to 90% of the American public doesn't know anything about what we're discussing. They have not got the technical background to even fathom what you're talking about. That's my opinion. I see I have some disagreement. Dr. Diaz, you talked about your waste disposal issue and 3,500 years of nuclear time. Did I get that? 3,500
reactor years.
Reactor years. You've all totally avoided the Navy. The U.S. Navy has more reactors in service than any civilian source does.
I did say civilian.
I know you said civilian, but you can't ignore the entire military complex of the U.S. Navy, which, to the best of our knowledge, has not had an accident with a reactor. It may be in front of the 26 million classified papers of last year, but it isn't obvious. You mentioned, I think you're Ed?
Mike?
No.
Ed. Yes.
You mentioned that we get into a problem with terrorist hazards if we go to distributed power. But the biggest problem we have isn't the reactors, it's the grid. Every time you do distributed power, you've got a spread of where you're going to be able to generate from if there is a disruption to the grid. And we're not doing anything about protecting our grids. It's stupid. Michael, I do have your name right. You mentioned the fact that you weren't going to build any coal plants. I wonder if your organization, Constellation Electric, has thought about what happened to the asbestos problem. 24 years ago, did you think 66 companies in the United States were going to go belly up on asbestos? It was used for medical treatment in 1920s. What's going to happen when the carbon dioxide problem hits the fan?
We're all going to have lots and lots of Diet Coke. And we're going to sequester the stuff. I could differ with you on the thresher, which was a problem with the reactor water intake, but I won't bother. I'll ask if...
Shall we just do the one we were asked to try to... So I'll just stay on the one I was asked directly. And actually, I disagree. 2 years ago, I would say, the dialogue around climate change and energy was remarkably primitive in this country. But whether it's Al Gore or other features one wants to, I think the dialogue has moved amazingly fast. In fact, much faster than most of the experts thought. And poll after poll indicates a strong amount of interest. Now, few of us, myself included, know how to fix many of the technologies in my home. But I have an opinion on them, and that opinion is actually valuable. And so I actually think that we've moved very quickly to a position where the dialogue is quite thoughtful. I received a call recently, actually 2 weeks ago, from a avowed, very conservative Republican member of the House. And he said, 2 years ago, I didn't know what global warming was. And he engaged with me on an hour and a half on the relative merits of a cap and trade system versus a carbon tax. And 2 years ago, he said he literally did not know the first thing. So in my opinion, actually, whatever set of forces has dramatically accelerated the discussion to a point where it is nationally exceedingly interesting. And we have a long way to go, but I actually think that the public is highly informed on the issues to debate. So I actually think we're pretty far in that process, and we're going to keep going.
And I do believe that the same thing is happening with nuclear power. I have been really all over the world. I interact still, even after I left my job at government, high-level governments, financial institutions. I actually see the sophistication of the dialogue, people calling and wanting to know what things are, facts, what is happening, what is the relationship between nuclear power and the environment, what is the historical data, what has been done to get better, what are the regulatory processes, how does China is intended to regulate, how does India is intended to regulate. All of those things are actually being discussed very much and every day at a higher level of knowledge and sophistication. And this is why this type of meetings are very valuable, and I want to thank both PBS and the National Building Museum for putting it together, because we need to do this. It needs to happen every place, and it needs to be an open dialogue. That's how we learn, how we progress. I see much has been gained in a year that I've been out of my federal position.
Are we wrapping up here?
Yes.
Wrapping up.
I guess in summary, I'd just like to say there's a lot of hype today about the so-called nuclear renaissance. And, hello?
Go ahead.
And I think we need to sort fact out from fiction. There is a large-scale PR campaign going on, which I think in some sense is trying to circumvent the kind of intelligent public dialogue that Dan was talking about. And I think we need to take a deep breath and confront some of the issues that have not been resolved that I've talked about before making decisions that we may regret later. So, for instance, does the nuclear industry in this country deserve not loan guarantees for the first few plants, but for potentially the first 30 or 40 plants, or even more, which is the way the rules for distributing these guarantees are being set up right now? Has the American public been consulted on whether they want to, whether taxpayers should underwrite potentially $50 to $100 billion in losses for new nuclear power plants? I don't think that dialogue is taking place, and we'd like to encourage that discussion.
Mike, you get the last word.
You raised up the military. I guess I have to point out I spent 5 years in the nuclear Navy in the submarine service. That's where I got my initial training. And they're extraordinarily safe. And the Threshers problem was not related to the reactor, actually. I can give an hour-and-a-half lecture on why the Thresher went down as the first nuclear submarine that we lost, but it did not have anything to do with the reactor.
But you put the operator inside the containment, it changes the whole attitude.
Nuclear power, in fact, the joke is when I was under the water for 3 months, I received less radiation living next to the reactor than my wife did, who was living in New England at the time, because there's so much granite that produces natural occurring radiation. So nuclear power plants are safe. I've been doing this for 38 years. The public that lives around them knows it. 3 Mile Island was just about the worst accident you could have. Nobody was hurt, let alone was anybody killed. And the core almost was a total bed of rubble, and it stayed where it was supposed to stay. Today, the plants are phenomenally more safe and secure than they were at that period of time. And the U.S. track record, as Nils said, speaks for itself since 3 Mile Island. And the nuclear plants today are operated very safely, very securely, very reliably, and very, very economically. The cost of operating a nuclear plant is 1/4 the cost of operating a gas plant. And your electricity bills are driven by the gas plants, because nuclear is only 20% of the electricity. Most of your electricity probably comes from gas, some comes from coal. So it is a technology that we understand. It's being built and deployed around the world safely. We just haven't done it here for so long that we need a little assistance to get those first 4 homes on the block built. And after that, it takes off on its own. And it needs to be part of the mix. It can't be the whole solution.
I want to thank our panelists and thank the audience, and we're here. We'll chat. There's cookies and coffee and all sorts of things. Thank you.
Thank you.